Friedel Crafts Alkylation reaction. When benzene is treated with an alkyl halide in the presence of anhydrous aluminum chloride, alkyl benzene is formed. So this is a way of substituting an alkyl group on a benzene ring. So the catalyst used, it is done in the presence of anhydrous AlCl3. Other substances like FeCl3, ZnCl2, SnCl2 or AlBr3, all these can be used. But the catalyst is very, very important. So let us look at an example. Say this is the benzene ring. Benzene is treated with, we are taking methyl chloride CH3Cl. This is in the presence of anhydrous AlCl3. Just we can see that this CH3 is getting substituted on the benzene ring. So something else is getting removed from here. So CH3 is coming in the place of the hydrogen on the benzene ring. You know that on each carbon of the benzene ring there is a hydrogen. So one hydrogen from here is getting replaced or substituted by this CH3, and that hydrogen will, with the chlorine, will give you HCl. Again, we can do one more example. Say benzene plus let's take CH3 CH2Cl, again in the presence of anhydrous AlCl3 will give you CH2CH3 attached onto the benzene ring, that is ethyl benzene. The first one was methyl benzene, or you call it toluene, and byproduct is HCl. Now if we take another example, say benzene on treatment with, say, monochloro, that is 1-chloropropane, that is CH3 CH2 CH2Cl. Again anhydrous AlCl3. You are getting isopropyl benzene. Now you must be wondering why that is so. So CH3 CH3, isopropyl benzene, or you call it cumene, and HCl as the byproduct. Now here you can see that what the reagent you used was CH3 CH2 CH2Cl. Now this bond has broken. Chlorine has gone away with the bonded pair of electrons, a negative charge. Here you get a positive charge on this carbon. But instead of this carbon getting attached with the benzene ring, it is the second carbon which has got attached there. This is a primary carbocation. That is the carbon to which the chlorine was attached, and this is the primary carbocation. This carbon is attached to only one other carbon. But you know that a secondary carbocation is more stable. So there is a change has occurred here. One hydrogen from here has shifted to this carbon in the form of a hydride ion, H-, and that has created a positive charge on this carbon. So the carbocation has become like this. So it has become like this. And the attachment to the benzene ring took place at this point. That is why you have got isopropyl benzene. So this happened because the consideration for a more stable carbocation. And you have to see that this happened in the case of compounds having, or alkyl groups having more than 2 carbon atoms. So the product you obtain is isopropyl benzene or cumene and HCl. Now let us look at the mechanism of the reaction. We know that this is an electrophilic substitution reaction. So this is an electrophilic substitution reaction. One electrophile is going away and another one is getting substituted. So let us see the mechanism. Mechanism can be explained in 3 steps. The first one is the generation of an electrophile, or generation or making of the electrophile. So the reagent we are taking is CH3Cl plus anhydrous AlCl3 as the catalyst. AlCl3 is electron deficient. It's a Lewis acid. So it is in need of electrons, whereas chlorine is having lone pair of electrons around it. So chlorine will happily donate a pair of electrons to AlCl3. And so the CH3Cl bond will get weaker and the chlorine will leave with the bonded pair of electrons. So you will end up with a carbocation methyl group CH3 plus AlCl4 minus. So this is your electrophile. So you have generated the electrophile. In the second step, it is the attack of the electrophile on benzene ring. So let us consider the benzene ring. Electrophile means it is coming in search of electrons. It loves electrons. So it is coming in search of electrons. And the benzene ring is an electron rich system because it has got its pi bonds. So let us consider a ring like this. There is a hydrogen atom here. On each of the carbons there is a hydrogen atom. In the presence of this electrophile, the electrons of this pi bond will shift to this position. And now this position is very electron dense. So this electrophile will also come and attach here. And you will be getting a product like this. Hydrogen is there and then CH3 is attached here. This bond is gone. This double bond is gone from there. But this carbon has developed a positive charge. And these 2 bonds are there intact. In the next resonance structure, we can see H is there, CH3 is here. This carbon will start pulling these electrons towards itself because it is electron deficient. And these electrons will form a pi bond there. But this carbon will end up with a positive charge. In the next structure, you can see double bond here and the carbon has pulled electrons here. So here there is a double bond and this carbon has developed a positive charge. In the next structure, now who will give this carbon electrons? There are no more pi bonds here. So this bond will break and the hydrogen will leave as H plus ions and the electrons will come in here. So as a result, the CH3 will be fixed there and the double bond will come here and the other bonds will be here. So this is your product, that is toluene or methyl benzene. Plus, what else have you got? This hydrogen has gone away as H plus or proton, H plus ion. That H plus ion is there. Now in the third step, we have removal of the old electrophile. So this is the old electrophile, this hydrogen, and the new electrophile is CH3 that has attacked and that is now attached to the benzene ring. Now removal of the old electrophile of electrophile, or you can say you have regeneration of the catalyst. Let us see what it means. We don't have the catalyst. We have only AlCl4 minus. We had AlCl3, but now it is in the form of AlCl4 minus. So AlCl4 minus plus H plus, that is the proton, will give you AlCl3 plus HCl. So here is your catalyst pack. So these are the three steps in the mechanism of Friedel Crafts alkylation reaction. So the reaction is electrophilic substitution reaction. The first step is generation of the electrophile. That happens when the reagent CH3Cl is reacting with the catalyst AlCl3. It is coming in contact with the catalyst and you are getting the electrophile. That electrophile attacks the benzene ring, and then the removal of the old electrophile, that is H plus, is getting removed, and that H plus on reaction with AlCl4 minus is giving you your catalyst back. So this is the mechanism of Friedel Crafts alkylation reaction. So in this reaction, benzene is treated with an alkyl halide in the presence of anhydrous aluminum chloride. Then you are getting alkyl benzene.